Hi, this is Wes Simpson with another edition of the summer session on Media over IP, brought to you by Ames and the VSF. With me today is Andy Rayner, who is Chief Technologist from Nevion, and he is going to be talking about large-scale distributed ST2110 deployment. Welcome, Andy.
Greetings, Wes. Looks like you're in a very nice place over there.
Well, you know, there's nothing like a good green screen and a virtual background. So
yep, and an excellent bit of keying as well. Yeah.
Yes. So let's get into it. I'm really interested in hearing what you have to talk to us about today.
Great. Thank you very much. Well, it's good to be with you all, whatever time of the day you're joining us to consume this webinar. Just thought I'd say a little bit about where I am. So I'm on the southeast coast of the UK, speaking to you from about a mile near the sea over there. And just to show you that the weather in the last few weeks here hasn't been the typical UK weather you'd expect. This is with the back garden, just to say it's beautifully sunny. And we've been enjoying some really nice weather, which is just as well, since we haven't been able to go to many places. Okay, a couple of quick slides about Nevion for those of you that aren't familiar. First of all, one of the passions and a fair bit of my time is consumed on us supporting and helping to evolve standards. So a lot of the main standards bodies we're actively involved in, and that's something that we're really passionate about pushing and promoting and being part of within Nevion. And another little shameless plug to say on the next slide that there's two key things that there's two key things that Nevion does. Video iPath and Virtuoso are our two main solution areas. But there's two things I wanted to plug on this space here. First of all is that URL for a whole lot of tutorials that I've been doing in the last few weeks during lockdown. Go and check them out. And also available is the PDF of our baseband to IP to virtualization booklet, which you may find useful, and that covers and expands on some of the stuff I'm going to be talking on today. So hopefully that's of use. Moving on to the next slide. One of the things that's been exciting in the last few years is seeing the advent of IP facilities come about and them start to mature. But alongside that, I start to leverage the benefit of not just putting IP in facilities, but actually joining these things up. And the main example deployment I'm going to be talking to you about today is actually an example of that. On the next slide, you'll see distributed production. This is a kind of a useful but simple graphic that one of my colleagues put together. And I think one of the things it's really good at doing is showing the different elements of distributed production. You know, you've got different facilities which are all very well and good, and you're using IP technology. You've got the other elements of, you know, venues, locations, events, all of those things that you're trying to bring together. And it's once you start to actually interconnect all of those things together that you actually start to gain the true benefit of an IP production system. If you look at this next slide here, I think the three key things that we're seeing as savings, which is really driving customers actually wanting to do this stuff. One is the sharing of physical resources in terms of studio floors, galleries, trucks, all of that real estate. The second thing is actually the sharing of the processing capabilities. So those processing functions, be they virtual or physical appliances that are doing those. And thirdly, and arguably most importantly, it's the sharing of the people resources, actually making the best use of the people you've got by having this dynamic interconnect. Now, within this environment, we've probably been doing IP facilities in some way, I guess, for about 5 years since the inception of starting to do this. But actually, one thing what we've been seeing, I would say in the last 18 months to 2 years, is a maturing of the deployment. So I've put this business as usual sign up because I think that's the stage we've got to now. We're past the early adopter stage, and we're at the point where people are actually starting to roll out facilities, as I say, almost as business as usual. However, we are seeing some trends, and scale is one of those things. as facilities are becoming larger and people are wanting to actually really scale up what they're capable of doing, we're actually seeing an increasing number of connectivity that's needed within the facility, and as we'll explore within the case study we're looking at and the examples, between facilities as well. And the other thing I think that makes us realize is that full abstraction of the technology is really necessary to actually allow you to control it, because being able to manually control 100,000 connections is completely impossible. So the abstraction from the technology is important. Now, onto this slide here about scale. Scale is something we're seeing various drivers on. We talked about the sheer number of connections. Now, part of that is due to the way, as we've moved from an SDI plant into an essence-based plant, inherently, where we did have one SDI signal, we've got quite a few signals, different signals, maybe multiple audios, as well as the video and other ancillary flows. So that breakdown to essence-based is driving one thing. Obviously, in terms of sheer bandwidth scale, the higher resolutions that people are wanting to do, and high dynamic range, and hopefully up and coming higher frame rate, all of those things are driving the requirement for higher resolution. And then that distributed production, which I talked about, is also really pushing us to actually need more and more capacity and more connections. So this is a little example slide diagram of the solution that I was going to be outlining to you today. And what you can see immediately is what this is actually basically a template for some of those distributed productions that I've been talking about, where we've actually got multiple locations where we're actually sharing two large system bases, where lots of equipment is centralized, and the remote locations are relatively thin in terms of equipment and are able to make use of those facilities and all of the central capabilities of the system. But also there is autonomy, and I'll talk about that between the resilient systems that we're putting up there. So moving on, one of the really, really important things that we're seeing as we, both within facilities and even more so as we start to actually federate facilities together and actually distribute production, is an overlying orchestration layer that actually is managing our resources and managing our connections and managing our bandwidths. That's been one of the most important elements. And that kind of applies to managing both the signals in the data plane, but also everything about how we actually share information about the resources and share those resources at the what I could call the control plane layer. This is the set of key overall requirements that the customer that we're talking about today had in this large distributed production. I won't go through all the points on this screen, but it's a large international set of connectivities with some pretty high bandwidths, both within the facilities and interconnecting facilities together. If we dive in a little bit more to look at the requirements of that project, you can see quite a lot of those points I've been making previously. Lots of different locations we're connecting together, new facilities being built, the desire to share resources and leverage that collaborative work of people from many locations being worked together, sharing resources, sharing signals, and sharing facilities. So this is kind of the key elements of the project. Now, in terms of the benefits that realizes, obviously, people are wanting to actually have more and more flexibility in the way they actually do productions. And what I find with the creatives is the more flexibility you give them, the more flexibility they want. It's a virtuous circle of flexibility there. But also making more use of resources. Many of the IP facility and multi-location IP facilities that we've been involved in, you've actually seen people suddenly being able to make use of equipment that's standing redundant for significant proportions of every day. And also, and we'll come on in a little bit, the reduced cost of bandwidth, because we're going to be talking about some of the compression technology which we're using as well. So moving on to some of the technical considerations here. So scalability is very important, and pretty well in all of the large deployments we're doing, we're a leaf spine architecture for the switching fabric is the way to give us the most flexibility for future scalability. As I've already said, SDN architecture is incredibly important to be able to explicitly control bandwidth, explicitly control the routing of flows, and know that you're actually managing all of the data flows and making sure that you actually have the quality of service that you need. And then we get on to the JPEG XS compression, and we're just going to unpack that for a couple of slides now. So when we were looking in this project about the options for mezzanine compression, we were realizing that the customer actually wanted obviously the lowest latency possible. Now, obviously, there are some latencies we can't do anything about, like the speed of light in fiber. But apart from that, we want to get it as low as possible. And going back 2.5 years when we were first discussing this, JPEG XS at that point was an up-and-coming technology. And the great thing about XS is it gives us pretty well the same mezzanine compression ratio that JPEG 2000 has been giving us for the last 10 years, but with a very negligible delay. If we're talking about international connectivity, then 1 millisecond really is, or sub 1 millisecond is negligible in the scheme of things. So that's been a really great technology to use. And here's a little bit more detail in this slide. One thing to point out that goes in collaboration with that is the dash 22 there, which is part of the ST2110 SMPTE suite. And whilst I was skeptical when we started talking about bringing in compressed essence into the 2110 suite, is actually proven its worth for these long haul interconnects. So moving on, just to look at a reminder of that ever increasing toolkit of SMPTE 2110 standards, and also the control standards that go with it that have been developed by the NMOS team. These actually give us all of the essences to transport the video, the audio, different types of audio, the ancillary data. We've actually got some work on at the moment about how we handle specifically standard definition. There's another part which actually is for use for slow-mo, for high frame rate for slow-mo, how we carry that. But that left-hand side, second row down, the compressed video is the thing that's been really exciting and enabler for us, because it allows us to actually interconnect facilities, keeping that 2110 essence environment, keeping it ultra low latency, but actually make much better use of that finite resource of the wide area interconnect. We'll go through the control plane bits a little bit later on. So some other things about this deployment, it's over 10 countries involved. As you've already seen from one of my other slides, a large number of endpoints that we need to connect. And I think a world first in terms of the application of the JPEG XS compression. So looking at the actual solution, our video iPath system is what we have been using to actually do the orchestration of all of the connectivity there. A lot of gatewaying of video and audio between the facilities with the JPEG XS compression, and then a couple of different vendors of IP fabrics to actually facilitate the local area and wide area connectivity. So that's the if you like, the building blocks. Just coming on back to time, I always like to talk about time somewhere in my presentations. And one thing that I've been thinking about in the last few months is the fact that what drove us to actually synchronize time in different locations, because we've been thinking about so far timing within a facility, largely speaking, but actually, get way back, I think in the UK, 1840 was when we developed Greenwich Mean Time, which was driven by the railways, because we needed to have common time between locations to allow us to do things. If we move on a slide and look at the this next thing, we're actually in a similar manner needing to think about common time in different locations, because the whole ethos that we've built the 2110 suite upon and our facility timing is effectively having a common timing reference, which is obviously very easy to do within a facility. But as we're actually moving across facilities, obviously there's going to be some phase offset due to the sheer propagation time over the wide area network, but it's important that our facilities are frequency locked. and effectively making sure that we actually do that allows us to actually have a common timing domain, typically derived from GPS, across the different facilities. And that's an essential part. That common time is an essential part of these federated facilities and the different locations in these many different countries that we're talking about in this solution. Another quick observation on a little bit of technology. We've still been inheriting, even within the 2110 suite, some of the legacy of raster scanning, and very specifically, as you'll see in this next diagram, the vertical blanking interval and the implication of kind of the gapped timing, which a lot of people are using within the transport of data, especially as we come out of what I would call hardware equipment that's delivering our HD or UHD video frames. Because in the new world, where we don't have to have that raster flyback, we don't have to allow those gaps. Typically, we're tending towards a more linear distribution of the data over the whole video frame. But actually, as we do go to and from this gapped to linear environment, we have some moments of time that we can think about saving in the way we actually unify the timing behavior, especially between compressed and uncompressed essences. Not time to talk more about that now, but I'll unpack that for you later on. A few more vital statistics from this project. We've already talked about the sheer number of flow connections, a large number of compressions for interconnects as well between different locations, leveraging some high 400 gig spines there, because the sheer number of flows in the locations actually needs that level of interconnect. And also, again, and we'll come back to the audio again in a minute, a lot of audio interconnection as well, which is why we've got lots of these channels available where we can actually do the processing. Another comment of another toolkit that's needed here is what I call SDN to IGMP bridging. Most of what we're doing in the infrastructure in these facilities is an SDN architecture where we're explicitly controlling the flows, each of the flows, and therefore managing the bandwidth and the routes that all of the individual flows are taking. But inherently, in a lot of these designs, we're seeing IGMP islands where people are needing to interface between the two. So in that IGMP world, we actually need to understand the IGMP requests, join requests, and actually feed that into our SDN system and back again. So that IGMP to SDN interaction for those islands is very, very important. Okay, moving on. This is just an expansion now of the architecture, a little bit more of a deep dive into the video and audio flows in the architecture we've just talked about. So in the next slide, you'll see the video architecture. And this is just an example of showing that we're actually not only within the facility, but within the wide area networks in these designs, actually using 2022-7. So we're using that in the local infrastructure, but we're also using that over the wide area network to achieve the resilience. So we're compressing and we're using that -7. Also in the wide area network, typically, in some solutions, we're seeing the requirement for FEC. This is the audio diagram. It shows a very similar approach where we actually use that dual diverse routing. Again, not all studio audio equipment necessarily has that dual presentation, but we've been making sure that as we go into the wide area networks for these solutions, we're actually doing that dual replication to give us that seamless RTP layer healing of the audio flows as well. The audio itself is pretty complex in lots of these facilities. In fact, I would arguably say that the audio actually in lots of these deployments actually turns out to be the most complex piece, not only because of the sheer volume, but because of the toing and froing that the audio needs to do and the plethora of different options there are. This next slide is quite busy. I hate having a slide with a lot of text on, but it just goes to show the different number of options that we've got in the different ways that we can handle audio between our original AES-3, the MADI AES-10, the AES-67, and then the 2110-30. And there are lots of different choices within there. But actually, when we boil it down, we actually only need very, very few of them. But we are seeing the requirement to actually hone that down. So moving to the next diagram here, we can look at the audio manipulation that we actually are wanting to do. And now, because we're in this all IP domain, we need to do those conventional audio manipulations to tweak the gain or to add some delay or shuffle around, or come back to the shuffling in a minute. All of those kind of things are very, very important, but we need to make them happen in an IP to IP world. So looking at that shuffling and what we need to do, there's various mindsets people have had with audio in the designs as we've approached some of these facilities. One of the mindsets is to take everything down to a bare mono AES-67, because then you can inherently route each individual essence. I'm much more of a person that likes to keep phase coherent audio together in a flow, be that a stereo, be that a 5.1, or be that even bigger. What we're also seeing is lots of interconnects where typically you're bulk transferring either via MADI in a kind of asynchronous manner, or via high channel densities of AES-67 up to 64 channels. But the question also is, how do you actually optimize it for the consumption of different devices? We have some devices in the studio plants that can only take stereos, some that needs it in 8 channels, some that again needs to consume in monos. So what we actually are finding is that templating a small number of options and actually cross manipulating in the IP domain between these options is actually the most appropriate way to go. And we've got kind of 2 different centric audio manipulation toolkits that we've come up to solve that. One is what I call video associated audio manipulation, which is everything to do with the audio that's inherently linked to the video, be that in an SDI signal, a native SDI, be that in a 2022-6, effectively SDI within IP, or be that linked to a 2110-30 flow. But as well as that, we then have what I call the audio only stuff. So the MADI, which isn't necessarily synchronous to the audio, typically other asynchronous audio feeds coming in from different locations that need to be timed in. And of course, we still have within plant AES-3 and analog signals, which we need to bring in to the timing domains that we're actually having as well. So that's the audio data flows. And then one of the biggest challenges has been the control plane. Not just for the audio, but for the video as well. And this is where the standardization of the control plane with the NMOS suite of specifications is possibly, I would argue, not as mature as the data plane is. The adoption within the industry has actually got to a good point, but it's still not all-encompassing. Added to which, the toolkit of NMOS at the moment doesn't give us all of those bits we need, but we'll come back to that in a minute. This IP to IP processing world, I think, is interesting because the projects in the last 2 years really are those projects where we've actually started to see us doing true IP to IP processing, both for audio and video within these infrastructures. Typically, a lot of the functions that we've been manipulating had been kind of handing off from SDI on one side, or HDSDI or UHD SDI, and manipulating something and maybe going back to SDI or then going into IP. Pretty well in these infrastructures we're now deploying, as we're exempling here, we're actually manipulating both the audio and video, but keeping it in the IP domain all the way through, which is where we've been intending to get for the last 5 years, but it's really starting to happen in recent times. Just coming back to time, I always have to come back to time a couple of times in my presentation. One of the other opportunities we have within the 21 toolkit, which is not really being fully exploited everywhere yet, and it's something that I think the industry still needs to work on as we move forward, looking for other opportunities, is how we actually manage the automatic tracking of time. Now, we have a gift within the 2110 suite of the timestamping, the RTP timestamping, which is stamped at the origination time of both the video and the audio and the other essences that we're creating. And as we actually process them, if the equipment honors the propagation of the origination time and some of the adaptions we're making or the amendments to the 2110 suite at the moment help us to reinforce these approaches, we're able to then automatically, at whatever point we are, and indeed wherever we are in the different distributed locations, we can actually create automatic alignment of the essences at the use time across the different locations, which is very important. Now, there's a whole load of things that we need to look to do at the facility edge with IP, and I'm going to do a shameless plug for some standards work that's ongoing at the moment now within the Video Services Forum. There's a couple of different projects. The one that I'm chairing is the 2110 over WAN, which obviously is very appropriate to this, where we're looking at trying to actually standardize all of the things we need to do, both in the data plane and the control plane, as we get to the edge of these facilities and handoff. So that's a really important bit of work. And there's some parallel work with moving to the cloud. So as we draw to a close, we think about this distributed architecture that you can see again here. What are some of the things that we've actually had to do to get to doing this point? Well, one of those key things is evolving the way we have actually defined the architecture of our orchestration system. So the orchestration systems typically have been designed for campus and, designed originally, back in the day for SDI infrastructure. And as we've gone up many orders of magnitude, if you think, only 5 years ago, a 1024 squared router was typically what you were using in a reasonable size facility to switch your feeds. We've now gone up 2 decades to 100,000 flows. So we've actually had to redesign and scale the way we actually do control plane architecture for orchestration, both within a facility. And then as we get to this distributed architecture, we need to have control plane architectures that work both within facilities and then actually work when we're actually aggregating them between facilities. So that's been some of those real challenges of scale there. So in summary, this scale is ever increasing in what we need to do, driven not only by what the creatives want to do within plants, but also by the fact we're actually trying to work and federate multiple plants together to actually leverage even more benefit. This SDN control is absolutely essential. The JPEG XS, it's now 12 months since we started first deploying this on this solution for the very first time. So actually it's well proven now. I know other people are starting to bring that to the market now, but we're very comfortable with the maturity of the solution using XS now. And just jumping to the bottom of that list, distributed production, I think, is really starting to demonstrate the true benefits of IP. We're not now just replacing SDI cables with IP wires. We're actually sharing facilities, we're sharing equipment, and we're sharing people, which I think is a really, really great place to be. So that's been a whistle-stop tour of these this large deployment we've been working on. If you've got any questions, as always, would love to hear from you. That's my cell number and that's my email address there. And as I always say when I end a presentation, if you're ever in the UK, do reach out to me and we'll meet up for a lovely cup of tea, because I can make a nice cup of tea. So it's now back to that man in the sunglasses somewhere over wherever he is for the Wes, where are you?
Hey Andy, I'm still here, luxuriating in the sunshine. So
oh, beautiful, beautiful.
So that was great. Thank you so much for doing that. I really appreciate it. One question I did have, a lot of the things that you've been working on over the past year sound like they're, making a lot of progress. Specifically JPEG XS and things like that. What do you see as being some of the big obstacles to that still need to be overcome for deployments going forward from now, the second half of 2020 and into the future?
Yeah, I think probably the biggest challenge we have is the control plane, and specifically, there are 2 challenges there. One is the adoption of NMOS. That suite of standards across the industry still isn't full enough for systems to be truly plug and play. We're getting there. We're approaching that point, but there's still space to go with people truly adopting NMOS fully on all their systems. The other thing is NMOS as it stands doesn't actually address all the needs we have in the control plane. And very specifically, I've talked a little bit about the audio there, but the audio is a key example where you need to manipulate more stuff than NMOS, the toolkit really allows you to at the moment. And also as we move into compressed essences, we don't have the toolkit to control the compression either. So more of the parameterization of the control space is really where we need to actually do some more work. I think the data plane, the signal interconnect is in a really good place now across the industry, but that control plane still has some movement to go. So that's probably the biggest challenge still as we do new deployments moving forward for now.
Sure, and it sounds like those issues apply to any type of deployment, but maybe if you could talk a little bit more about, you know, what's coming out, or what do you see as changing to really support these large deployments that you've been talking about? You know, there's obviously some barriers you had to overcome. Do you see the industry moving to address those issues?
Yes, and I think you know, certainly from our side where I'm sitting, you know, in Nevion land, we've been forced to address them, as I said, driven by the sheer scale and the scale both of individual facilities and the scale of federated facilities. And I think it's the nimbleness of the control plane architecture, the orchestration, the SDN orchestration, that's actually really driving and enabling what we need to do there, because you need facilities need autonomy, they need to work on their own, but they also need to work fully effectively in a collaborated and federated manner. And it's the nimbleness of the orchestration that we've had to develop to actually get that hierarchy that I think is one of the most exciting things that we've achieved in recent times. Yeah.
So you think that the products are coming along to address that?
Yeah. We're starting to mature that. I mean, it's always going to be a journey, sure. And as I say, scale is still growing. So we're still seeing even more ambition from facility federation across, you know, many facilities within countries and between countries in different deployments. And it's managing that scale in an appropriate and effective way, I think, is the big challenge. But I think we're working well there.
Well, very good. So thank you so much for joining us, and I'm glad you were able to talk about an actual installation that's been done instead of just having to talk about something theoretical. I'm sure you learned a lot of lessons along the way.
Absolutely. I'm just going to see if I can fit my hat on here to join you here in the sunshine. Yeah,
that looks
great
good.
To be with
looks
you.
good. You know. All right.
Wasn't designed for these headphones, though.
Well, you know, there's people who like headphones and people who don't. So I think we've got to accommodate both in this world, you know.
Absolutely. Very good. Very good.
And you just like me, you know, you have to have some covering up there when you go outdoors. You know?
Oh, tell me about it. Yeah, can't risk that. Yeah, always
really
make sure you're protected. Yeah,
there you go. All right. Well, thanks so much, and have a great afternoon, and we will be talking again soon, I'm sure.
Take care, Wes. Thanks,
right.
everyone.
Cheers.
See you later.